All right. We're going to do 9-3 today. So we have done graphing before, many times, right? We have graphed lines, lots. We're at least kind of decent at graphing lines. We graphed exponential functions not too long ago. That was trickier, but we mostly just put a bunch of point numbers in there, connected the dots, right? In today's lesson, we're going to learn about graphing parabolas. We're going to graph quadratic functions. So, the functions that we've seen so far are linear functions. The linear parent function is y equals x, right? And it looks real simple, right? It's a straight line with its y-intercept being at 0, 0, and its slope being 1 over 1, right? And so it looks just like this. That's a linear parent function. We've learned a little bit about exponential parent functions. Right? We learned that exponential functions have two parents. Has exponential growth that looks like this. Both of them cross at 0, 1. Exponential growth starts low and goes high. Right? And exponential decay is similar, but it starts high and goes low. Right? It still goes through 0, 1, but it starts up here, drops down, and goes like this. Right? So those are the parent functions we've seen so far in this class. There are lots more. We're going to focus on a new one. The equation of these are parents you have to have kind of letters, right? Because there's slightly different versions, but it's AB to the x, right? Depending on what B is whether you get this one or this one. But A and B are numbers, right? Okay. So, the one we're going to learn about today is the quadratic parent function. Okay. We have been talking about quadratic equations. What makes something a quadratic equation? We learned about this in Unit 8. What's different about a quadratic than just a linear equation? What did all the equations we have in them last unit? Okay, so specifically a polynomial with what was the highest exponent in there? No, it was a 2, right? We had an x squared term, right? So the parent function for quadratics is y equals x squared. Okay. And its shape, the shape of a linear parent function is a line. The shape of exponential is exponential graph. It doesn't have a cooler name than that. The shape is called of a quadratic function is called a parabola. Okay. And the parent function looks like this. It has a vertex at 0, 0. Right? The same idea as a linear. It has some critical point at 0, 0. It is symmetric about the y-axis. And it looks like this. The parent function, just this one, it has a vertex right here at 0, 0. It also, just the parent function, goes through the points 1, 1, and then it's mirrored over here at negative 1, 1. Right. Making sense so far? Easy peasy so far. Okay. Now, just like a line, we can move it up and down, and we can twist it, right? This is not the only way to do a line. We do that by changing numbers here. That works the exact same way with a quadratic. It actually works the same way as an exponential. We've kind of seen this pattern before, but we're gonna spend a good chunk on it this time. Okay? So, this is called vertex form. You know, with a line, we can have it in slope-intercept form, right? Y equals mx plus b. Or we can have it in point slope. Y minus y1 equals m times x minus x1, right? We can put it in different forms, right? And the different forms tell us something. Vertex form is very useful for a quadratic, and it looks like this. It looks like y equals a times x minus h in parentheses squared plus k, right? These different letters do something if you change them. Okay? The k is real easy to understand. The k is a vertical translation. Okay. So if k is positive 2, it would go up. If k was negative 6, then it would go down, right? So it would take this whole, if we change the k, it takes this parabola and it moves the whole thing up or down. Make sense? Pretty easy peasy? Okay. The h is a horizontal translation. Okay, and we're going to use a phrase, inside opposite. To remember how it moves. Okay, so inside the parentheses, it could be x plus 5 or whatever, or x minus 6 or whatever else, right? So if you look at x plus 5, you would expect it to move 5 to the right, right? That's what you would think. But inside the parentheses, we want to think the opposite, and it's because of this minus here, right? So this one would actually shift 5 units to the left. This one would actually shift 6 units to the right. Okay, so inside opposite, it goes in the opposite direction of what you'd expect. Okay? Making sense so far? Okay, we have one more letter. That's A. A controls the dilation and reflection. If you go to the eye doctor and you get your eyes dilated, what happens to your eyes? Your pupils get bigger. So the dilation, if A is big, if A is 6, then what this does now, this is vertical. Now this is kind of where it gets a little bit tricky to understand what's happening. This is vertical. Okay? So if A is like 6, then it stretches up. If A is like 2/3, then it compresses down. So see, this looks like my hands are bigger, but they're going down. Right? So fraction is going down. So you got to think about it not as left and right, but as up and down. Reflection is if it's negative. If it's negative, then the whole thing goes and it flips up down below. Making sense so far? Let's do some examples. Let's graph several different things. Okay. Let's graph y equals x squared plus 2. So there's 3 letters that you can change. Which one did we change? A, H, or K? Is it inside the parentheses or outside? It's outside, so which letter is that? Well, A is multiplied, but yeah, they're both out. K is the one that changed. So how does this change this? Is it going to move, or is it going to stretch, or is it going to compress? Which one is it going to do? It what? Verticalizes by 2. It moves up 2. It moves up 2. Okay, so let's graph it. So normally the vertex is at 0, 0, right? But ours moves up 2. So it goes up 1, 2, and the vertex is now here. So to get to our kind of points, we go up 1 and over 1 and up 1 and back 1. So we go from the new vertex up 1 and over 1, and we put a dot. Up 1 and back 1 and put a dot. And then connect those shapes, connect those dots like a parabola. You can get more points if you want to do more. So we just did y of 1 and y of negative none. You can do y of 2 and put a 2 in there, right? 2 squared plus 2. What's 2 squared? 4 plus 2 is what? 6. If we were to put negative 2, it'd be the same thing. So at 2, it's up 6. Right? It's a little wider probably than what I drew. All right, so you can still plot points just like we've always done, right? Okay, let's do another one. Okay, so how does this one change the parent? Down 5. It's a good idea to jot down yourself a note of how it's changing. Right? It's going to go down 5. So it's the same idea, right? I'm going to graph it. Our vertex normally is at 0, 0, so we go down 5 from that. So down 1, 2, 3, 4, 5. We put a dot. Up 1 and over 1. Up 1 and back 1, right? If we want
all the way up to the very top or just to the 0?
For these ones,
Yeah,
we're counting from the vertex, right? That's why they're down here. So up 1 and over 1 just from there.
Right. When you do the lines, would they go all the way up to the very top or just the center?
No, they go all, it keeps on going. That's why there's arrows on there. Yeah. We could get another couple of points. We could put y of 2 in there. What's 2 squared? 4 minus 5 is what? Negative 1, right? So 2 and negative 1. So right there, and then a mirrored point on the other side, right? So it looks about like this.
You don't have to have those extra points.
Not necessarily. Okay, let's do another one. All right, how does this one change the parent? Yeah, horizontally which direction, left or right? It moves, remember, inside opposite, right? So you'd think left, but since it's inside, it actually is going to move it to the right. So it's moving it to the right 3. Right? So let's graph it. So it normally is at 0, 0, right? We're going to go to the right 3. Right? We put the vertex right there. And then we go up 1 and over 1. Up 1 and back 1, right? We can even plot a point. What point would be over here? What number would we want to find? 1, 2, 3, 4, 5. Let's do y of, you could put 2, but then it would just be this point, right? Y of 5 equals 5 minus 3 squared. So 5 minus 3 is what? 2. What's 2 squared? 4. So 5 and then 1, 1, 2, 3, 4. Up here and there. And then there's one that's mirrored on the other side, right? So we connect the dots, make it look like a parabola. Okay, let's kick it up a notch. Are you ready? Let's kick it up a notch. Let's do this one. Let's do y equals x minus 1 squared plus 2. So now there's 2 things that happen. So how does this one change the parent? Up 1, up 2, up 2 to the right 1. That's right. And then we graph it. No, that just says it's going to be a parabola. Okay. So, the vertex is going to be right 1, up 1, 2. So the vertex is going to be right there. Right? And then from there we count up 1 over 1 and up 1 back 1. Let's get one more point on there. So we've got the 2, so what are we're gonna do? How about just 1 over 3? Y of 3 equals 3 minus 1 squared plus 2. What's 3 minus 1? 2. And what's 2 squared? 4 plus 2. What is 4 plus 2? 6. It's going to be at 3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. It should be about the same shape, assuming I did my scale the same size, right? And there's going to be one that mirrors it on the other side, right? So over here at -1. And it looks like that, right? Huh? It doesn't look the same. Well, it's because we're only seeing like this much of it. And also I didn't draw my scales perfect, right? So that'll change the look of it a little bit. Okay, let's do another one. A jumbo size. We are going to start messing with the A, so we could have a jumbo one. Okay. Example, what, 5 maybe? Y equals negative 2x squared. Okay. How does this change it? It doesn't move up. No, that's not what happens. It doesn't move down either. What did I say the negative does on the A? There's 2 words on the A. What are they? You have notes, like flip a page or something. What 2 words go with A? Dilation and reflection. The negative one is in charge of which? The dilation or the reflection? The reflection. So this stretches by 2. 2 stretch. And it reflects. So instead of opening up, it's going to open down and stretch by 2. Okay, so let's graph it. Okay. So the vertex didn't change, right? There's nothing that changed on the H and K, so the vertex is still 0, 0. And we can prove that, right? We put a 0 in here. What's 0 squared? 0 times negative 2 is 0, right? So the vertex didn't change, right? So it's still 0, 0. It flips down. So normally we would count down 1 and over 1 if it was just negative. We're going to count down 2 and over 1, and we're going to prove it with doing the math on the dilation. When it is dilated, usually we want to do a few more points than we would normally do because it's going to be a little bit trickier to look at. Okay, so let's prove that. So we're going to do y of 1. What's 1 squared? 1. What's 1 times negative 2? 1 times negative 2. Negative 2. So that's the 2 points that we just did. So let's do one more. What are we going to do? Y of what?
Y of 2.
2 sounds great. What's 2 squared? 4. What's negative 2 times 4? Negative 8. Right? Let me back up. Negative 2 times 4. That's addition and subtraction. Negative 1, 2, 3, 4, 5, 6, 7, 8. So here and here. Okay, so just to compare, so you can see what it would look like. If this was just negative x squared, it would have gone through this point and this point, and 2, 3, 4. It would have gone through this point and this point. So if it would have just been negative x squared, it would have been just like the parent, but flipped over down. But the negative 2 makes it stretch. Okay, let's do one that's a little bit harder that we definitely want to use some points for. Let's do y equals 2/3 x squared. So what does this do? It doesn't stretch, it compresses, which is the opposite, but it is the dilation, which is what when you're saying it stretches by 2/3, that's kind of right? But a stretch by 2/3 is actually a squish. So it's going to take and it's going to compress vertically, right? That's what's going to happen. So let's get some points. Where is the vertex of this one? Did the h or the k change? Yes or no? It's still 0, 0 because it didn't change. That's right. So the vertex is the same as it was. So the vertex is easy peasy, right? It's right here. 0, 0. Is this parabola going to open up or down? It's going to open up because it's not negative. The a is still positive, right? Okay, so let's get some points. So what do we want to plug in there? 1's fine. That's great. Y of 1. What is 1 squared? 1. What's 1 times 2/3? 2/3. Okay, so go over 1 and up 2/3, which makes sense, right? We said it's compressing, so it's not up 1 over 1. It's not over 1 up 1. It's over 1 up 2/3. Same idea as this, right? This was over 1 down 2, right? This is over 1 up 2/3, right? Easy peasy. You're going to have a mirrored one over here. Let's grab another one. Let's do y of what? What do y'all want to do? Let's do y of 3. Let's do y of 3. 7 is a bad choice. No, let's do 3. Because that's going to be easier numbers. You could do 2, that would be fine, but 3 is going to give us a pretty number. Yep. What's 3 squared? 9. What's 2/3 of 9? It is 18/3, but that reduces.
Wait, I got it right. 7 or 6.
It is 6. Y'all were way slower than the calculator. Guys, don't forget your middle school stuff. 1, 3, 2 times 3 is 6. Pre-reduce. It's easy money, dudes. Dudes. 2, 3. 1, 2, 3, 4, 5, 6. 2 and 3. All right. And then that's right there. So it compressed by 2/3. Just to compare, right? The parent would go through here and here, 2, 3, 4, and here, and here, and look like this. So see, it's not compressed by much, but it is some, right? A little bit.
Quarter inch.
Okay. All right, let's do another one. See if there's anything I'm like actually missing and forgetting. There's not. That's great. We're going to do one more, and then we're going to do 1 or 2 as guided practices, and then we're going to be done. And then on Thursday, we're going to learn how to solve a quadratic equation if it won't factor, by making it be factorable. Once? I think it's been a few times, bro. All right, example, I don't know. Y equals -1/5 times x plus 1 squared minus 2.
This would be 7.
Sure, sounds great. No, this is not guided practice yet. The next one's going to be. All right, how does it change the parent? It goes down 2 right 1. Well, that does not go up 1/5. What does that do?
It makes it down.
It reflects, right? And then what else does it do? Does it stretch or compress? It goes, oh yeah, it does go left up, right? That's wrong. Does it stretch or compress at 1/5? Is it stretching it or is it compressing it? It's compressing it, right? It's a fraction. It's less than 1. Well, that one was also less than 1. Compress 1/5. Right? All right. Let's go to be graphing it. Well, one of the points we know. Where is the vertex? It's at -1, -2. And it's going down, so it's going to go over 1, down 1/5. So little bitty, right? And then back 1 over 1/5. Let's get one more point. Let's go with 1 right here and 1 right here. So what number are we going to put in?
5.
Guys, why do we keep going bigger than we need to? 1 is the next number in the thing. Y of 1. So you could do all those numbers you're saying. You're just going to get, it's just the further out you go, the crazier the numbers are going to get. So keep it simple. -1/5. 1 plus 1 squared minus 2. So what is 1 plus 1? 2.
1.
5th times 2 squared. What is 2 squared? 4. What is -1/5 times 4? Yeah, negative though, right? -4/5 minus 2. What is -4/5 minus 2?
That's what I was doing.
It is -2 4/5. That's true, it is. No, that's right.
Okay, I thought I've been doing it wrong for a long time. Wait, wouldn't it be positive?
No, because the signs are the same, so you add and keep the sign, right? If you're multiplying, it would turn to positive, right? So, 1 and -2 4/5. -1, 2, and 4/5. So it's still not even down to the 3, but it's closer, right? And then you're going to have a mirrored point over here. And then you can connect your dots.
On these you have to add extra points.
When there's a dilation, you really should, because it's going to be a lot easier to understand what's happening. There you go. That's easy peasy. Let's do 2 of them as guided practice. I'll write them both.
We don't have to choose problems.
No, you don't choose. You do them both. All right. Y equals -x plus 1 squared plus 1. And then guided practice number 2, y equals 3 times x squared plus 5. What's up, bro? Okay, ready to go. That's crazy, bro.
Right there. Vertical means
Up and down. Horizontal, like the horizon, right?
Horizon 5.
You are welcome to try guessing. I don't care if you guess. I would definitely watch the lesson though at some point, so that you don't have to just guess.
Unless I get it correct. So, which I won't.
Crazy, bro.
But then these two just can't figure it out.
No, they don't.
You go up and then down.
No.
Wait, do you have
The
to
inside isn't up and down. Inside is left or right.
I did do it.
It's crazy. Guess your axes are going to be crooked. So, how did we do on the first one? Oh yeah, so remember inside opposite, right?
Got it. I thought it.
Yeah.
I switched.
You switched what?
I thought it went up instead of down.
It does go up.
So on
No,
the
like the.
Oh, the negative it
A board,
flips it.
on the A board, negative.
Did you do any points? Okay, well do some points and you'll figure that out. And you'll realize, oh wait, I was thinking wrong, right?
I know how to do the points.
Do the second one if you haven't done it already.
It is
Oh,
positive.
so I'm not gonna do this right.
Hmm.
If it's like the A one is positive,
It's going up, yes. Mm-hmm.
so yeah, it gets wider.
Well, it's a 3, so does it stretch or compress? Compress means get smaller, so that'd be like between 0 and 1, like fractions. So it stretches up. So it actually gets narrower because it's stretching up.
I have a question.
Yes, sir.
On the first one, in the parentheses was 1, but in the second one it was 2.
And the second one, well, because I picked 1, because that was just the nearest number. You could have done y of 2 if you wanted to. And then you would have found the point that was over here. This one, I already knew the one that was 1 because I know how to get those because it's just over 1 and then up 3. Okay? But I used 2 because that's the next one out. Let's do another guided practice. I changed my mind. Don't give me that face because did you graph either one correctly?
I grabbed the second one.
Good. Well, not the first one, so we need one more to make sure we got it good, right? Right. Yeah.
Oh, bad. At least you got the basic.
Y equals 5/8 x minus 4 squared plus 2. Ready, go. What?
I forgot there was a line inside.
Definitely
dot
gonna
had to
be
be at zero.
Huh?
Another dot had to be at zero.
No, because it changes.
I did.
I did that.
It's not-
Yeah,
it's just-
what you did was counted.
I'm gonna sign over.
Okay.
But I just did it. That had to be at zero.
And one.
Yeah, and I wouldn't have waited for you.
You have to take it outside.
Or I could do it while it's Or home.
Get on the computer. What is the?
What is the answer to print out?
Okay. How did we do on these?
So good.
Better.
What do you mean better?
Like I just didn't draw my curves.
Oh yeah, you just failed at art class part.
It's just trying to.
The math was good. The art was failing a little, but
You're like this. Oh, yes, yes, yes.
all right, your homework is on page
385,200.
Oh, let's start opening it. What one am I on? You know what?
Yeah, we're going to go ahead and assign those numbers.
No.
Try them. Try 24 and 26. Don't just skip them. Don't look at them and be like, I'm dumb, I don't know anything, because it's false.
That is true.
Page 569, numbers
One.
10 through 28 evens.
That's not bad.
Okay? Ready, set, go.
What?
Oh, leave? Or,
Yeah, you can leave if you want to.
oh,
I mean, you got 5 minutes left in class if you want to start on it.